we are going to solve the past papers. So let's see this kind of question. Ali was on a training run. The diagram is the speed time graph of the part of his run. His speed decreased at a constant rate until it was 4 meters per second. His retardation during the 200 second. Okay, we are going to calculate retardation during the 200 seconds. Okay, so basically we are gonna calculate this one, this portion, because this portion is of retardation. Here our coordinates will be 200, 4, and here it will be 0, 8. As this is speed time graph, so we will be following DSA from speed to acceleration. Retardation is an acceleration, negative of acceleration, so it will be gradient. We are going to choose gradient. So gradient is A equals to y2 minus 1. This will be equal to y2 is our 4 minus 8 over 200 minus 0. So our acceleration is going to be minus 4 over 200, which will be 4 divided by 200 is 0.02. So minus 0.02 is our acceleration. As I told you before, minus 0, retardation. I told you before, retardation basically is a negative of acceleration, okay? So whenever I'm going to write the retardation, I will take the magnitude. Retardation tells the negative of acceleration. Retardation, acceleration. So minus will be positive 0.02 meter per second square. That will be our answer for retardation part 1. Okay, his distance, the distance he runs during the 200 seconds. Okay, we are going to calculate the distance now. As you can see that we have to disintegrate. They already have made this into shapes. So we can split this, we can choose the formula for the shapes, or we can choose the formula for the trapezium. It's totally our choice, okay? Whatever we want to do. Let me make some space. Just give me a moment. All right, I'm going to calculate the distance over here. The distance he runs during 200 seconds. Okay, the distance he ran during 200 seconds is going to be this whole distance. DSA rule. DSA rule says that if I'm having speed time graph and forward, I have to take gradient. Okay, so area under the curve will be for this whole portion. Okay, so I'm going to use the formula for the trapezium. So area is equal to half plus 8 times height. Height will be 200 seconds. Okay, so it will be 4 plus 8 is going to be 12. 12 times 100 is 1200. So 1200 will be our distance. Ones are, 200s are. So I can simply cross this one. Instead of that, I can simply write it. And this will be 1200 meters. That will be my distance for the whole journey. His speed is at t equals to 150. Okay. So I'm gonna now let me clear my graph first. All right. Okay. Now it says that his speed at 150. Okay. Let's see. Let's make it half. I'm gonna make it half as it is of 1 mark. So we have to use graph to calculate that. This will be 100. And half of that 100 here, it will be somewhere 150. Okay. Now I need to figure out the value of this one. So I will try to draw the exact line, this one. Okay. Now let's match this point on y-axis and see what will be our result. Okay. So for that, half of this, like let's make them half. Half of this will be this one. 4 and plus half of that is gonna be, let's divide it into 4 parts. 1, 2, 3, and 4. Okay, 5, 6, 7, 8. So that is approximately 5. So it says that his speed at 150 will be 5 meter per second. Let's move to next question. Next question says that Ben ran at a speed, constant speed in the same direction as Ali. Okay. They ran at the same distance in the next 150 seconds. All right. Okay. Ben ran at a constant speed in the same direction as Ali at t equals to 0. Ali and Ben were level. They ran the same distance in the next 150 seconds. Calculate the Ben speed. We know that as it says that the distance are same. So distance of Ben is equal to distance of Ali. So distance of Ben, what will be the distance of Ben? We know that speed times time. And for this one, distance, to calculate distance of Ali, as we have the graph, and we know that from speed time graph, we have to take area under the curve according to DSA. According to DSA, we have to calculate area under the curve. So for that, I'm going to choose this whole trapezium. This whole trapezium will be considered. And this length is 5, and this vertical length is 8, and this one will be 150. So it's going to be half sum of parallel sides. A. For this one, my speed is u. I have to calculate speed, and time is 150 seconds. So let's simplify that. 13 times 150 by 2. So that is 6.25. Almost that will be my time in second. Let's cross check and divide it. 13 divided by 2. It will be 6.5. 6.5. So that will be my time. 6.5 seconds. Let's move to next question. And our next question is, all right, it says that the diagram shows the speed time graph of two objects, A and B, for the first 10 seconds of their motion. Object A traveled at a constant speed of 12 meter per second throughout the 10 seconds. Object B starts from rest, the acceleration at a constant rate, attaining a speed of 20 meters per second. Okay. The distance traveled by object B during the first 5 seconds of its motion. We are going to calculate the distance traveled by object B. This is object B during the first 5 seconds of its motion. Okay, this is speed time graph, DSA rule. Whenever we see a question, we have to see either DSA rule is gonna apply, is gonna work on it or not. Okay, so here in this question, DSA is working. So we will be seeing looking for that DSA. So he's asking for distance. So from speed time graph to distance, we have to take area under the. So it says that for object B, this is object B. So we are going to consider this whole portion. For first 5 seconds, it will be having 5 seconds and vertical length will be 20. I'm going to calculate the distance traveled for first 5 seconds. Part 1, A, part 1. It will be half base time 10 are. So 50 meter is my answer. Now, average speed for the object B for the first 10 seconds of the journey. Okay, to calculate average speed, I need the formula for the average speed is average speed. So my total distance, I need to add this portion as well. And this one is 5. Vertical length is same as 20. So total distance is gonna be 50, which I have calculated over here because this portion is also included. So 50 over total time. Total time is 10 seconds. So it will be 50 plus average speed is gonna be 150 over 10, which is 15 meter per second. That is my average speed. Let's move to next question. Before that, I need to make some space. All right. So what does it say now? Okay, now it says that the value of t when both objects were traveling at the same speed. Okay, look, we are going to calculate this value. At this point, you can see that their distance was almost same. The value of t, suppose that this was a t because they were crossing their path. Okay, the value of t when both objects were traveling at the same speed. Okay, they both were traveling at the same speed. This shows that I have to consider 3 points like I told you for type 2 questions. For type 2 questions, what have we done? We were doing that like we were considering their acceleration same. Is it clear? I hope I have cleared your concepts. So what will we be doing? We are going to choose few points, like 3 points on the same graph. One will be this. Second one will be this, and third one will be this one. We will be choosing these 3 points, okay? Because it says that the value of t, we have to calculate the value of t. The value of t when both objects were traveling at the same speed. We need to calculate the value of t when both objects were traveling at the same speed. So we are considering that this time is t. So as we have no clue for that, I'm going to equate their gradient, okay? Because they were traveling at the same speed with the constant rate. So their acceleration is supposed to be same. Okay, when their accelerations are same, so let's figure out their time. T, comma 12 and 5, comma 20 is equal to, okay, 0, 0. That will be like 0 as well. So let's equate the gradients. Like they were moving with a constant rate, like their acceleration was same. So first coordinates will be T, comma 12. Its gradient is going to equal to coordinates because they are on the same line, their answer is going to be same. So it's totally up to you. Over t minus 0 is equal to 5 minus 0. So 12 over t is equal to 20 by 5. Let's cross check. 5 by 20 is equal to t. 3 seconds. So our time, this time is 3 seconds. That was our time for that. Now, it says that the fourth part says that the value of t when both objects has traveled the same distance. We are going to calculate the value of t when both objects had traveled the same distance. Calculate that. What are we going to do? The value of t when both objects has traveled the same distance. Okay, look. It means that we are going to calculate the time t now for that point. Look, let's assume with the different color. I'm assuming that there was somewhere the time t, okay, when they both have covered the same distance, okay, because we don't know exactly. Either was it the 10-second was their ending point, okay, so we don't know exactly what was the time. I'm assuming that this portion, like I'm making a trapezium now, having 5 seconds, 5-second time, and vertical length is 20. Okay, same way 20 minus 5, okay, or let me write it with the different color because this is not so bright. So this is t minus 5. Let's equate their distance now. To equate their distance, now distance for object A and object B, their distance is same. For object A, distance is going to be same because like length time breadth, area under the curve, area under the curve, distance A is equal to distance of object B. For distance A, it's going to be area under the curve. And area under the curve is this one is 12. 12 times, this will be whole T, 12 times T. 12 times T. And for distance for object B, it's going to be a trapezium. Trapezium is sum of parallel sides. This portion, upper portion is T minus 5 and sum of parallel side is half, or we can do this separately. Like we have calculated this portion. So we can use that, this portion, because we have already calculated the value for this portion, which was 50. That is over here. So I can directly use this part. By directly using this part, I will save my time. So 50 plus. Now I will find the distance for this portion, for this rectangle. It will be half base into height. Base is t minus 5 and times height is 20. Let's simplify that. And it will be 50 plus 12t. It's going to be 10t. Sorry. Sorry, it will not be like it was a rectangle. So for the case of rectangle, we don't need to try divide it with half. Plus 20t minus 100 and minus 50. Then 50 is simplified. I hope you understand it well. So 50 equals to 80, which is equal to 50 by 8 is going to be, let's divide. 50 divided by 8 is 6.25. 6.25 is the time over here. So this time is 6.25. This one is 6.25 was the time when they both have covered the same distance. Let's move to next part. Okay, next part says that the diagram shows the distance time graph for object B. Okay, that is the distance time graph. Now, in the diagram, OP is a curve and PQ is a straight line. What does the gradient of the straight line PQ represent? The gradient PQ. Okay, first it says that, let's zoom out few things, explain. All right, it says that state the values of D1 and D2. As we know that we have calculated the values of D1 and D2. D1, this point, D1 was this 50. For this portion, D1 was 50, like distance time graph. And for this portion, D2, we have calculated D2 as well. And it was this one. Let me highlight it. This is 150. So this is a 1 mark only. We will use calculator. We will use graph to calculate that value. So D1 is 50 and D2 is 150 meters. Now it says that what does the gradient of the straight line PQ represent? Gradient of the straight line. As we know that distance time graph, this is distance time graph. So according to DSA, if I want to take the gradient of distance time graph, then gradient of distance time graph will give me speed. Okay. So gradient of PQ says that this is a speed which is constant. Okay. Now let's see that, write down the gradient of the tangent to the curve at t equals to 2.5. Let's take the gradient of the curve. First, we are going to divide this portion. Half of this is going to be almost here. And this will be the point where gradient will be. I'm going to draw it from here. And same from here. Let's consider any two coordinates. By considering, okay, okay, write down the gradient of the tangent. First, let me tell you one more thing. As it is the gradient of distance time graph will be speed. So the speed time graph of this one is over here as well. So I'm gonna figure out my gradient, the value of gradient from here. So what will I be doing at 2.5? I will be choosing different color to differentiate it. Look, half of this is almost here. This is almost half, which is 2.5. Now let's see the value of speed from here to here. Look now, if this is 4, 8, 12. 4, 8, and 12, half of that will be approximately 10. It will be approximately 10. So that will be 10. Okay, so gradient of distance time graph is a speed. So our speed will be 10 kilometer, 10 meter per second. Here my speed will be 10 meter per second because it is a 1 mark question. We don't need so heavy calculation. You can directly use graph to calculate it. Now after 10 seconds, both objects slowed down at the same rate. Both objects were slowed down at the same rate. Now what are we gonna do? After how many seconds from the start of its motion does object B comes to rest? All right, look, it says that their rate is same. As their rate is same, I'm going to make some space over here so that I can solve my question. Look now, for this part, it says that their rate is same. They were over here. Both objects slowed down. They both were slowing down after 9 seconds. Okay, like object A was slowed after, like after this 10, it was like it slowed down after 10 seconds. Like it further took 9 seconds to come to rest. So it says that what will be the time when object B will come to rest. Okay. And it tells you one more thing. It says that it is moving with a constant rate. Okay. It means that their deceleration will be same. Okay. So when their deceleration will be same, so we can say that it's going to move with like 12 by 9. That will be the deceleration rate. Speed over time is acceleration. Na? They are moving at the same rate. So speed over time can give me acceleration. So I will be writing here as acceleration is same. So acceleration of A is equal to acceleration of B. And acceleration of A, its acceleration is basically 12 over 9. That will be the same for the next one. 12 over 9. And for B, acceleration for B, look, B has covered 20 meter per second speed. Okay, so I'm going to find the time for that. I will consider the time T for it, and I will be writing here as 20 over T. Let's cross multiply. It will be T equals to 20 times 9 over 12. So it's going to be 20 times 9 divided by 12, which is 15. Okay, look now, it says that it comes to rest after 15 seconds. But we can see from here as well, from our graph, we can see that it has covered some time till 10 seconds. And after 10 seconds, it has covered, it again has covered further 15 minutes to come to rest. So my final time will be, T will be 15. So it says that because it says that from the start, that's why I need to include this 10 as well. Okay, so object B comes to rest, so it will come to rest after 25 seconds. I hope you have cleared your concept till that. Now let's move to next question. Next question says that okay, the distance time graph represents Brain's car journey to work on Monday. How long does his journey take? Okay, we are supposed to calculate the time. To calculate time, I need to zoom it in so that we can figure out the time. Look, what can we figure out? We can figure out the time for that, which will be like in minutes. As I told you before, whenever a clock is given, we have to consider time in minutes. But luckily over here, he wants us to calculate the time in minutes as well. Okay, so let's figure out the minutes over here. This is basically 10 minutes. From here, it's 10 minutes, 10, same 10 and 10 until here it is almost 7. 1, 2, 3, 4, 5, 6, 7. Okay, this is 5. So 5 minutes further. So this is 5. It's gonna be 35. So minutes are 35. Here we will be writing here 35 minutes. Now during the first 10 seconds, he traveled with a constant acceleration. Find the acceleration in kilometer per hour per hour. Okay, first 10 seconds. So that is first 10 seconds. His acceleration, that is the 10 second. I'm gonna meet it with my graph and see the values. According to DSA rule, according to DSA, from speed time graph to acceleration, I have to take gradient. To take gradient, I need two coordinates. One coordinate will be, that is basically 10 minutes. Okay, but I need to calculate in hours, so I will convert this 10 minutes. 10 minutes will be equals to 10 by 60 hours. So that will be 1 by 6, 1 by 6, comma 60. Okay, so let's calculate the acceleration. Acceleration or gradient minus 0 over 1 by 6 minus 0. That was in kilometer. 360 kilometer per hour square. That will be our acceleration, which we have covered. Okay, third part, it says that how far does brain travel at its maximum speed? First, we are going to see that where is his maximum speed. Let's zoom in. Look, this part is his maximum speed only. How far? So this shows that we are just gonna calculate the distance for this portion only. He says that how far does it go with its maximum speed only. Okay, I'm going to calculate the distance only for this portion. For this portion is this as well, and I will calculate the distance for that. Look now. For this portion, this is almost 5 minutes. 5 minutes. And this vertical length is 84. Move backward. I have to take area under the curve. To take area under the curve, it will be, that is kilometer. We need to calculate how far distance in kilometer. And you can see that DSA, according to DSA rule, my distance will be speed times time. Time is 5 minutes. So let's convert 5 by 60. This is per hour as well. So let's simplify. It will be 7 kilometers. That is our answer.